Okay, this is the fourth set of notes for the exponential chapter. We're going to be focusing on changing the base and exponents of equations. So for example 1, it says Deshaun is in his 5th year of employment as a patrol officer for the Metro Police. His salary for his first year of employment was $43,000. Each year after the first, his salary increased by 4% of the salary from the previous year. So for the letter A, the equation will be S of t equals, starting salary is $43,000 times the quantity of 1 plus his interest rate of 0.04 raised to the t minus 1. Reason it's to the t minus 1 power is because he doesn't get the raise until he puts in a full year of work, so you have to subtract out that first year. Letter B wants you to find what would his salary be after 5 years. So we are going to plug 5 in for t. So you'd have 43,000 times 1.04 raised to the 5 minus 1 power. And if you notice this right here, there's 1 plus 0.04. You can condense it and write it as 1.04. Now, 5 minus 1 is 4, so you can raise 1.04 to the 4th power times that by 43,000. And you should get an answer of 50,303 and 92 cents. So that's for letter B. Letter C wants to know what is the sum of his salary over the first 5 years. So we have to figure out his 5 years. You know the first year is 43,000. We don't know the second or the third or the fourth, but I know the 5th year is 50,303 92 cents. So what you would have to do is use the calculator and calculate how much he makes after the 2nd year, the 3rd year, the 4th year, and then you add those 3 totals up. So go ahead right now and try finding the 2nd, 3rd, and 4th year, and then add all 5 years up. Your final total for this should be $232,901.87. So make sure, again, you find all 5 years and then you add those 5 together. So now moving on to the back of the first page. It says when changing exponents, you must also change the base. And you're going to fill that in on the top of the page. So we're going to practice some changing base equations. So letter A is 2 to the x power. And I want you to rewrite this as 2 to the first raised to the x. Notice now you can clearly see what is your base and what's your exponent. So the directions say they want you to change the base from being x to 2x. So I would multiply my exponent by 2. But since you are completely introducing, you need to divide the exponent by 2. So using a calculator, you have to raise 2 to the 1/2 power. Now, when you type it in the calculator, you need to make sure you do 2 raised to the 1/2 power. If you don't use the parentheses, it's going to raise 2 to the first power and then divide your answer by 2, which is not what you want to happen. So when you do this, we're going to round to 3 decimal places, and you get 1.260 raised. I'm just kidding. That's to the 1/3 power. 2 to the 1/2 power is 1.414 raised to the 2x. So letter C, again, same thing. We have 1/2 raised to the x power. So again, this is 1/2 to the first power. If I want to multiply, change my base, I would multiply this exponent by 2, which means I have to divide this exponent by 2. So 1/2 raised to the 1/2 power is 0.707 raised to the 2x. And letter C is 6 times 5 to the x. Now there's extra information here. The 6 just follows you along. The 5 is the base. So 5 is raised to the first power. And I am going to multiply my exponent by 2, which means I had to divide this by 2. So 5 to the 1/2 power is 2.236. This is raised to the 2x, and the 6 is just out front, follows you along. So now we're going to skip down to the next example, and we're going to actually apply this go to a word problem. This is a problem that I took directly from the practice park. So it says, during a 1-week period, the population of bacteria grew according to the model P equals P times 3.57 raised to the T power, where P is population, little p is the initial population, and T is time in weeks. Write an equation that can be used to model the the daily growth rate. So 2 words that are important is that T is in weeks. So right now T is in weeks. And we want it to go from weeks to daily. So in that last sentence it says daily growth rate. So we know 1 week is equivalent to 7 days. So I need to change this T to be 70, so it's in terms of days. So if I'm dealing with this 3.57 raised to the T, well, that means I'm going to multiply T by 7. And if I multiply T by 7, that means I need to raise this to the 1/7 power. So when you do 3.57 to the 1/7 power, you get 1.999. So this will be raised to the 7t, and the equation just still follows suit. So that is all you have to do for that one, is just raise it to the 1/7 power, again keeping it in parentheses. So now you're going to skip down to the last example on that page. And so at the bottom of the page, the directions say change the exponent from x over 2 to 2x. So again, we're going to rewrite it as 2 to the first raised to the x over 2 power. And if I want to get rid of this x over 2 or clear the fraction, I would be multiplying my exponent by 2. By multiplying by 2, that means I have to divide by 2. 2 to the 1/2 power is 1.414. And up here, since I introduced this 2 into the problem, this 2 will cancel out with that 2, and I'm left with raised to the x power. So letter B, we have 1/2 raised to the x over 2 power. Again, same thing. If I needed to go away, I would multiply by 2, which means I need to raise this to the 1/2 power. So 1/2 raised to the 1/2 is 0.707 raised to the x. And lastly, letter C, we have 6 times 5 to the x over 2. Again, the 5 is your base, not the 6. We'll multiply this exponent by 2, which means I have to raise this 5 to the 1/2 power. 6 days, 5 to the 1/2 power is 2.236 raised to the x power. So the process still is the same as before. Very repetitive once you get the pattern down. Last thing we need to do is, if you go to the final page of notes, there's one last example, and that example says a scientist places 8.7 grams of radioactive element in a dish. The half-life of the element is 2 days. After t days, the number of grams of the element remaining in the dish is given by the function r of t equals 8.7 times 1/2 raised to the t over 2 power. Rewrite the equation so the exponent is t instead of t over 2. So we don't need to deal with the 8.7, we need to deal with the 1/2 raised to the t over 2. So this is taking that skill that we just practiced. If I need this to go away, I'm going to multiply this by 2, which means I have to raise this to the 1/2 power. So by doing that, 1/2 raised to the 1/2 power is 0.707. So my equation will become r of t equals 8.7 times 0.707 raised to the t power. So that would be our answer for letter A. Letter B says, by what percentage is the amount of radioactivity going down by each day? So essentially they want to know what was the percent. And whenever we're doing these exponential formulas, it's always 1 plus your rate value or 1 minus your rate value. So if I wanted to figure out what percent was there before I got to 0.0707, we would do 1 minus the 707. When I subtract this, I get 0.293. So this means it went down by 29.3% each day. So that's all for today.